Let's look at this word problem that will require solving a quadratic equation. One positive integer is 7 less than twice another. The sum of their squares is 269. What are the numbers? We have two unknowns, one number and another number. We'll need to use a variable to represent these unknown numbers. The strategy that I like to use is to first find the sentence that compares or relates the two numbers to each other, and that's going to be this first sentence, that one positive integer is 7 less than twice another. And in this sentence, which does talk about both of our numbers, the number that they talk about second in the sentence is the one that we're going to make equal x. So I'll go to this other number and say it equals x. Next, what do we use to represent the first number? We go back to this sentence and we will try to translate this sentence. So this one positive integer, the one that we're about to find, one number, is, there's the equals, 7 less than. Now 7 less than, if you're thinking minus 7, that is great, but we're talking about 7 less than something. What that means, the 7 less than, basically is we're going to subtract 7 from something, from whatever we get to next in this sentence. That's what will happen when we get to this phrase, less than. We'll have a minus 7 behind what we get to next, twice another. Well, twice means times 2, and another, we decided that we will use x to stand for the other number. So twice the other number is 2 times x. The 7 less than is 2 times x. We're looking at 2x minus 7. That's the first part of this problem, the representation. How are we using variables to represent our unknown numbers? The next part of this problem is to set up the equation. That's where we use the second sentence. The sum of their squares is 269. We will use our variable representation here. The sum of the squares means if we take our first number and square it, sum, so we will add it to the second number squared, and it will equal 269. There's the equation, and we know to use this equation based on this sentence. The sum of their squares, sum of each of these numbers squared, and I think it is a good strategy to throw parentheses around those expressions once we go to write the equation. That will keep our math accurate. The last part of this problem is to come up with the solution. What are these numbers? And this equation is quadratic. We will want to get it into standard form, but first I want to simplify the left side. I need to do some exponents of 2. Here we are multiplying 2x minus 7 times another 2x minus 7. I'll do FOIL method. The outer and inner terms are both minus 14x. When we combine those, we'll have minus 28x. And then negative 7 times negative 7, positive 49. Let's bring down the plus x squared equals 269. Let's get this equation into standard form and collect all of the terms on left side in descending order so that we can have equals 0 on the right side of the equation. 4x squared plus x squared will make 5x squared minus 28x. We will be subtracting the 269 from both sides to get that equals 0. On the left side, the subtract will leave us with minus 220. Here's the quadratic equation that we are going to solve. We're going to solve it by factoring. To factor this trinomial that we have on the left side of the equation, since we have a coefficient of 5 on our leading term, this would be where I would ordinarily multiply the first term, the first coefficient on that first term, with the last term, the constant, but that will leave us with a pretty large number. And the next part of this problem is to figure out what pair of numbers would also multiply together to equal negative 1,100, but added together would equal our middle coefficient, negative 28. And that might be a little bit painstaking. There isn't really a very quick way, but a different option would be that we use prime factors. So when we're multiplying 5 times 220, I could just list what would be the total prime factors after doing that multiplication. We would definitely have the 5 that we start with. What prime factors do we have of 220? Well, maybe we'll just do a tree. We have a 2. There's going to be another 2. and 5 and 11. Listing the prime factors, we have 2 times 2 times 5 times 5 times 11. Now, when I'm coming up with this pair of numbers, I will come up with these factors based on factors that I see in this list. For example, I could choose, what if I choose doing the 5 times 5? That's 25. And the leftovers, 2 times 2 is 4. 4 times 11 is 44. We know it needs to equal a negative 1100. That means one of these numbers would be negative, and added together should equal a negative 28. So our larger number is negative, and it looks like added up we'd get to a negative 19. So it's not the two 5s. What about if we use the 5 and 5 and 2? The 2 times 5 is 10, and 10 times 5, 50. Left over we have 2 times 11 is 22. If we make the larger number negative, add it up, it equals negative 28. That's what we're after. Next, we'll split this term, negative 28x, up into two new terms using the negative 50x and positive 22x. Bring down the 5x squared. The minus 220 equals 0. Next is to factor by grouping. We did have a common factor of x minus 10, and the other factor 5x plus 22. Since this was an equation equaling 0, we can split these factors up into two separate equations that equal 0, and solve these to come up with our answers for x, the solution. First, x equals positive 10. Over here, if we take away 22 on each side, then divide by 5, our other solution, x equals negative 22 over 5. Remember, this problem is about positive integers. This answer, x equals negative 22 fifths, we're going to ignore for this problem. It did work out mathematically, however, the problem is asking for positive integers. We will use, for the rest of this problem, x equals 10. Now, just because we have x equals 10, we're not finished with this problem. Remember, what did x stand for? And what are we trying to find to answer this question? Go back to the beginning of the problem where we laid out our unknown numbers using variables. And now we know that x stands for 10. So our another number, where we said it equals x, now we know it equals 10. Our first number, the one number, was 2x minus 7. Now this x right here, that is, now we know it is 10. In fact, every x that we've been using so far in this whole problem, now we know that all along it really has just been a 10. It's now a known number. But let's finish this one up. Our first number, 2x minus 7, is 2 times 10 minus 7. That looks like 20 minus 7 equals 13. Our two numbers in this problem are 10 and 13. We can even do a quick check. First sentence. One positive integer is 7 less than twice another. Well, let's take the 10. Double that would give us 20. And the other number, 13, is 7 less than twice the first number. So that first sentence checks out. What about the sum of their squares is 269? 10 squared plus 13 squared, will this equal 269? 100 plus 169 looks like a good check. So I'm confident with our answers, 10 and 13.